Good morning, students. Today we are going to study about diet or dead reagent. These two reagents are slightly different, but they show the same kind of properties. The only difference is between the alkyl group present here and here. If you see, it's isopropyl group. Here it is ethyl group. Now, if we look at the structure, this is diet. Full form is di disisopropyl azodicarboxylate. So if we write first azo dicarboxylate or azodicarboxylic acid, so the structure will be this. This is your azodicarboxylic acid. Now what is happening here is ester formation. So basically diet is a diester disisopropyl ester of azodicarboxylic acid. It is disisopropyl ester of azodicarboxylic acid. And here only the difference is you have ethyl group. Remaining things are similar: diethyl azo dicarboxylate. So basically this is diethyl ester of azodicarboxylic acid. Diethyl ester of azodicarboxylic acid. It's a very good reagent for producing many organic compounds, and a name reaction is there in which it is used: Mitsunbo reaction. Okay. In this reaction, ester of alcohol is generally prepared from a secondary alcohol. So the reaction we will see later. But first of all, we will see the preparation. It is prepared by reacting hydrazide with 2 molecules of ethyl chloroformate. It's a two-step process. NH2 NH2. This is our hydrazide. 2 molecules of ethyl chloroformate. Ethyl chloroformate. If we have to write ethyl formate, so the formula will be this, but it is ethyl chloroformate. This hydrogen is replaced by a chlorine group. So I'll open this and then write. So this is our ethyl chloroformate. Presence of sodium carbonate. Basically what is happening, chlorine group is here. So one chlorine and one hydrogen from here and another chlorine and another hydrogen from it will be eliminated as HCl, and you will obtain a let's say alkylated product. So one side we have C2H5. Similarly, on the other side we have C2H5. So this is where you have ethyl group. So you will be obtaining dead as the product. अब वो मिलेगा कैसे? स्ट्रक्चर क्या है डेड का? This is the structure. So the only difference is ये hydrogen molecules remove हो रहे हैं and you are getting a double bond. That means you have to perform oxidation. Oxidation करने के लिए generally this solution is bubbled with hypochlorous acid. Hypochlorous acid is obtained by HNO3 and chlorine gas. So basically what it is forming hypochlorous acid. How it is produced? Nitric acid is added and chlorine gas is bubbled through the solution. So it produces hypochlorous acid, which in turn oxidizes this and gives us a side group here. So once again, if we look at the reaction, this is our hydrazide and ethyl chloroformate in presence of sodium carbonate. 2 molecules of HCl are removed. This is obtained on oxidation. Our dead is obtained. If instead of this ethyl group we had isopropyl group, so we have obtained diode as a product. Okay, so that's how it is prepared. If we talk about reactions, so the reaction is Mitsunbo reaction. What happens in this reaction is in this reaction we take phosphine and our 1-carboxylic acid and reagent, that reagent or dyed reagent, and the reaction is performed on alcohol. So basically alcohol plus acid will give us ester. Let's take one general secondary alcohol. ये आपका secondary alcohol हो गया. Let's take a carboxylic acid, that too a general carboxylic acid. Phosphine and the reagent. Basically here ester formation is happening. And here inversion of molecular symmetry takes place. If this OH group is above the plane, you will get this as below the plane. If we look at the second reaction, it is hetero Diels-Alder reaction. So the reaction is very much similar to the Diels-Alder reaction, but what difference is here? In Diels-Alder reaction, we have till this time we have studied that we get a cyclic ring. generally 4 plus 2 addition is there, and we get a 6-membered ring, and that ring have only carbon atoms. But in this case 4 plus 2 addition is happening, but COOR, the ring obtained is heterocyclic. Similar thing, Lewis acid के presence में you will have the reaction. Reaction का mechanism क्या है? You have this, इसके ऊपर substituent है, I'm not writing it. आपका 4 plus 2 cycloaddition हो रहा है, तो you will get a product. In this case यहाँ नाइट्रोजन है, यहाँ नाइट्रोजन है, and you will get a double bond here. तो आप ऐसा प्रोडक्ट मिलता है. एंड इन ट्रेडिशनली डील-सेल्डर रिएक्शन यू हैव स्टडीड, अगर ऐसा है तो you get a product like this. So the mechanism is same. The only difference is instead of alkene we have a diester of azodicarboxylic acid. ठीक है. So the product obtained in this case is this substituent will come as it is, and one double bond here. Now this diene could have any number of substitution. So I'm writing an alkyl group here. That alkyl group will remain on its own position जहाँ भी रहेगा. So it would so you can easily predict the products. Let's say कि आपका reaction है this plus your dead in presence of a Lewis acid. You have to predict the product. Similarly, varying the different substituent, you will be given a reagent. There is a possibility that dead is not written there, but instead you have been given the structure. So be careful, look at the structure, identify that it's a dead reagent or diet, and there is a Lewis acid present here. So there is a possibility of Diels-Alder reaction, and you will get a hetero product. Okay.